Hi, so in today's lesson, we want to look at the general method of actually differentiating functions. Alright, so first example we're going to take is this: when y equals to x squared, what is the derivative dy dx? What is the derivative of that function dy dx? So then the general method for actually differentiating any function is if you have y equals to x to the power of n, then the y dx has to be, bring down this n, then you have x, then this n raised to the power of -1. So this is how to differentiate a function using the general method. So let's do that with this as well. So we're going to have y equals, the question is actually y equals x squared. Then so to find the y dx, we're going to say, we're going to bring down these two, and I'm going to bring down these two as a coefficient. Then that becomes the y dx becomes 2, then x, then you have this 2, then you have 2 minus 1, and of course 2 minus 1 is actually 1, and so that gives us 2x. So therefore the y dx is actually 2x. So this is the answer. The y dx equals to 2x. Alright, so here we have this other question. X is equals to p to the power of 6. Now, why I used these letters is because sometimes in differentiation we use different letters to represent different functions. So we have s, so we are asked to find the change, that's ds dp. So what is ds dp? So you have to say ds dp. So this 6 has to come down to become the coefficient, and so you have 6 ds dp now becomes 6, then p, then since you have 6 as the power here, so you have 6, then subtract 1 from the power, so you have 6p raised to the power of 5. So this is how to differentiate. So let's take another example. So if you have let's say y equals to 5x to the power of 3, then the y dx has to be 5, then into bracket. Now you have this x to the power of 3. How do you differentiate this? Bring down this 3, so you have 3, then x, then you have this raised to the power of 3, you have 3 minus 1, and so you have 5 into 3x to the power of 3 minus 1 is 2, and so you have 5 times 3 is actually 15x squared. So that's it. Then let's see another example. Let's say you have y to the power of 3x. What's the derivative of this, the y dx? Now the y dx is actually, if you differentiate 3x, you should get 3. So, and that's because x is to the power of 1, okay, and that's because x is to the power of 1, so we can write it as 3x raised to the power of 1. So if I bring 1 down, I have 3 times 1, then I have x 1 minus 1, because you have to take away 1 from the index. So you have 3 into x 1 minus 1 is 0. Anything raised to the power 0 is 1, so you have 3. That's why you have it here. Okay, good. So let's take one example. So you have y equals 6x plus 5. Let's say 6x squared plus 5. How do you differentiate this? So the y dx has to be 6 times 2, that's 6, then times 2, then x2, subtract 1 from the index 1. And so plus, anytime you differentiate a constant, let's say 5, the derivative is 0. If you differentiate 3, derivative is 0. Differentiate 15, derivative is 0. Any number without variable, it's actually 0. Any constant without variable or any number without variable is a constant. So when you differentiate a constant, you have 0. 50, 1 million, differentiate 1 million, you have 0. Alright, so then our derivative here now becomes 6 times 2 is actually 12x, 2 raised to the power 1 is 1. And so we have 12x, and that's the derivative of that. So let's take another example. Let's say y equals 3x to the power of 5, then plus 2x squared plus 4x plus 3. Now this is kind of long. So the dy dx is actually 3 times 5. That's 3 times 5. Then x to the power of 5, subtract 1 from the index, minus 1. Then plus, bring down this 2. That'll be 2 into times the 2 you brought down, 2, then x into power 2 minus 1. Then anytime you differentiate 4x or 7x, so that's 4. You differentiate 7x, you have 7. You differentiate 10x, you have 10. And when you differentiate another number like x, like 3, you have 0. Okay, so then dy dx now becomes 3 times 5. You have 15x to the power of 4. Then plus 2 times 2 is actually 4. X 2 minus 1 is 1. Then plus 4. So my total answer is actually dy dx actually becomes 15x to the power of 4 plus 4x then plus 4. So that's my final answer for this. So this is how to differentiate polynomial functions, very simple functions. All right.